Welcome to College Algebra. In this lecture video, we are going to begin our Chapter 5 lecture video series regarding to the exponential functions and their graphs. So before I talk much about exponential function, I would like to take a step back and review some of these exponential the exponent rules for the polynomials. So this is actually, you can actually put these underneath the review section of your notes. Okay, so we reviewed 14 different objectives. This is actually the last one, objective number 15, talking about exponential rules. The rules for the exponent, something called the product rule. As you're aware, product rule says when the base are the same and the base are multiplying, what we can do is add the exponents. So for example, if I have maybe something like x squared times x to the third power, when the base are the same and base are multiplying, we normally will add the exponents. So that'll be x to the fifth power. Okay, that's what the product rule says. Now I'm gonna rewrite it this way, okay? Because what we need to understand is not just how the rule is used from left to the right. We also need to know how we can use this from the right back to the left. So for example, if I will write you something like x to the 2 plus 3, which we know is x to the fifth power. But if I see something look like this with that plus sign, that tell me that my base x can be split up into x squared times x to the third. We can rewrite it this way. Okay, we're going to see something like this in chapter 5. Alright. Another rule is called the quotient rule. Quotient rule says when the base are the same and the base are dividing, what we're going to do is subtract the exponent. It's always a top exponent subtracts the bottom. So if I have an x to the second power over x to the third power, okay, the idea of a subtracting the exponent is basically cancel them out, top and bottom. So here we can write this as x to the 2 minus 3. Okay, so that means if I see something look like this, because that subtraction sign, I can split up my bases as x on top, x on the bottom, 2 exponent 2 on top, the exponent 3 belong to the base in the bottom. Okay, so this is going to be x to the negative 1 power, and according to the negative exponent rule, when my base has a negative exponent, we can flip the base to the other side of the fraction and make the exponent positive. So my base will come to the bottom. In this particular example, make the exponent positive. Since I don't have anything left on top, my numerator will just be 1. Okay, that's using the negative exponent rule. So if I have something like 1 over, you know what, let's do a 2. If I have something like a 2 over, for example, x to the negative 3 power. If I have an example that says 2 over x to the negative 3 power, I see my base x has a negative exponent, so I can flip it to the other side of the fraction and make the exponent positive. So my 2 remains on top. That base x flipped to the top become x to the positive 3 power. Okay, that's how we use the negative exponent rule. Now, we also need to understand negative exponent, the negative exponent rule from the right side to the left side. That means if I have a positive exponent, you know, maybe like a 2 over 3. Okay, if I have a 2 over 3, technically the 2 over 3, well, maybe it's not a good example for here. Tell you what, I'm not going to use that example. I'm going to just make up another one. if I have something like x to the 4th power, okay, even though it's a positive exponent, normally the answer can just be x to the 4th power. But if I have to, okay, what I can do is flip my base to the other side of fraction, and now this time I will make my exponent negative. Since there's nothing on top, it must be 1 on top. Okay, so even though I have a positive exponent, I can also flip my base to the other side of it, make the exponent negative. Okay, we can do something like that in chapter 5. Alright, power rule. Power rule, there are 2 different versions. Both of them is saying the same thing. We multiply the exponents. So in other words, if I have something like x squared whole thing to the 3rd power, by the power rule, it tells me to multiply the exponent. So that means I get x to the 6th power. Alright, power rule B is saying the same thing. If I have 2 different factors inside the parenthesis, okay, both of them raising to the 2nd power on the outside, raising to the n power on the outside, then my outer exponent will distribute its power or multiply its exponent on all the exponents of the factors in the inside. For example, if I have an x squared times y to the negative 3rd power, but the whole thing is raising to a 2nd power. So I got 2 different bases inside, both of them is raising to a higher exponent. So by power rule B, my outer exponent 2 will multiply the exponents. Okay, will multiply the exponent of all my factors in the inside. So that means I should get x to the 4th power times y to the negative 6th power. And normally in algebra classes, we will say, okay, y has a negative exponent, so my base y will flip it to the other side of the fraction. So this time you will come to the bottom and make the exponent positive. Only base remains on top is x to the 4th power. Okay. So that's what the power rule is saying, multiplying its exponents. Now, let's go back to look at this answer. When you see an answer such as x to the 6th power, okay, I need you to kind of understand that there are different ways to rewrite this back into the power rule. So power rule is multiplying. So what I can write is x to the 1st whole thing to the 6th. Because 1 times 6 is 6. I can write this as x squared, x to the 6th whole thing to the 1st. I can write this as x squared whole thing to the 3rd. Or I can write this as x to the 3rd whole thing squared. Okay, I got different way to write this. They're all going to be equaled up to the x to the 6th power. So now, Mr. Chen, which one do I use? Well, it really depends on other part of the question we are going to do. Alright, now with the rational exponent and the negative rational exponent rule. Rational exponent, I've kind of explained this before in other videos. When the exponents are fractions, they actually turn into a radical. Denominator determines the roots. Numerator tell you the base is raised to that power in the inside, or it can be the whole thing to the n power. Negative fraction exponent just telling you flip the base to the other side of the fraction, okay, and make the exponent positive. All right. So with these rules in mind, I just want to kind of briefly talk about them. So in a minute, when we do some problems, it won't be so bad. You won't be so unfamiliar with these rules. So back to the exponential function. What is actually considered as an exponential function is a function where the variable x, okay, your variable now is going to be on the exponent, where the base got to be greater than 0 and not equal to 1. Because 0 to the any power is still 0, 1 as a base to any power is still 1. So it's kind of boring. So I don't want my base to be 0 or 1. And we will denote our exponential function as a to the x power. A is being a base. And what kind of base are we using right now? We're using numerical bases there, because there's another base I will introduce in a different lecture video. Alright, so since the variable is going to be on the exponent, as my variable, let me scroll this down, as my exponent variable keep on getting larger, what's going to happen with my y value is it will actually increase very, very rapidly for the bases that's greater than 1. So this picture here on the right, all my base is bigger than 1. So when the variable is on the exponent and these x value getting larger and larger, that will actually tell me my y value will shoot up faster and faster. Now why is the yellow one here is actually the y value shoots up quicker? Because the base is larger. Okay. Now if the exponent is approaching negative infinity, okay, if the x is approaching to negative infinity, tell you what, I think I got this one wrong. I think as x approaching to infinity, the y value will decrease rapidly for the bases that's between 0 and 1. Okay, for bases, see, look at these bases are between 0 and 1. That means I will actually go from the other direction. So my domain will be from negative infinity. Okay, my domain is coming from negative infinity to infinity, but the y value is actually what? Decreasing. Okay, approaching to 0. Alright. So let me just graph a couple of them right here real quick. If I use the same one, 0.4, okay, raised into a positive x power, and I graph it, it will look something like this one here. Okay, now if I would say basis 0.4 raised into a negative x power, okay, and what will my exponent do? It will actually go back to the other direction. So these exponent and these bases will actually dictates the directions, okay, the directions how my graph will look. So if you look at these problems right here, 1/3 is 0.3, and 0.3 repeating base is going to look something like this, but this time my exponent is negative, so my graph will look very similar like the second one I just drew. So parenthesis 1 divided by 3 raising to the negative x power, you actually go to the right. Okay, so that will be the answer. Indicate which graph is the correct one. So what you can do here for the homework is graph them on the calculator and then select the correct choices. Alright, this is 1/4, but to a positive x power. 1/4 is 0.25, so my picture will actually decreasing as I'm going. My y value will decrease as I'm going to the right. Alright, so this one is already drew above. Now this one, you know, if you think about in terms of a transformation, the +1 will actually shift my graph upward, okay, 1 unit. 2/5 is 0.4. Okay, so my base is actually between 0 and 1, but my exponent here for the variable is negative x. So you will basically by the transformation, you will actually go the opposite way. What it normally supposed to be, this one. All right. So if I will graph it real quick. 1 plus parenthesis 2/5 raising to the parenthesis again. This is 2 terms for 1 exponent, so that's 3 minus x. This direction. There you go. Alrighty. So the plus 1 shift my graph 1 unit up. Alright. So these are the basic graph. What I really want you to get out of here is understanding that if the exponent becomes, if the variable lands on the exponent, you should expect your y value either will rise up rapidly or will decrease rapidly. Okay. And we will deal with more application problem in the next lecture video series. Okay. Alright, let's take a look at what we call the elementary exponential equations. Okay. So to solve this equation, we're going to use this idea of base exponent property. What it's saying is, if the base are the same and the base are equal, what we can do is set their exponent equal to each other. Okay, when the base are the same and the base are equal, we can set their exponent equal to each other. So these following examples, what I'm going to try to do is make all their bases the same, so I can set their exponent equal. For example, this 16 right here, this 16 and this base 2, you got two different kind of bases. Can I somehow make 16 into a base 2? So if you think about it, 16 is the same as 2 to the 4th power. Alright, so that's how I make the base the same. Now, on the top of the 16, it has an exponent says negative x power. So that means on the outside of my 2 to the 4th, which is my 16, I have a negative x power. So according to the power rule, I can write this as 2 to the negative 4x power. Multiply the exponent, which is equal to the other base is 2 to the 1st power. So when the bases are the same and the bases are equal, we can set their exponent equal to each other. So my answer, x is equal to negative 1 over 4. Okay, solving for the following variables. Alright, let's try this one here on the right. I'm going to move my 9 to the other side, because remember now these problems are called the elementary exponential equation, because it really consists of two terms. Okay, we just manipulate its exponents. This equation only consists of two. This exponential equation consists of two terms. So this is going to be 3 to the x power equal to positive 9. Alright, I can make base 9 into a base 3. So this is going to be 3 to the x power equal to 3 squared. So when the bases are the same and the bases are equal, set the exponent equal. So my answer, x equal to 2. Alright. Same thing, two terms. Everything is two terms on this handout. Okay, on this particular page. Can I somehow make the base 9 and base 27 the same? Yes, I can. Alright, this is what I'm going to write, okay? Base 9 can be written as 3 squared. But on top of the 9, there's another exponent that says x minus 4. So if I write them this way as like a power rule, multiply the exponent. So this is going to be 3 to the 2 times parenthesis x minus 4. Because x minus 4 is two terms. Okay, so the 2 will multiply both terms in a minute. Alright, 27 is 3 to the 3rd power. Alright, so on the outside of 27, I have raising to a negative x plus 1 power. So now what I can do is by using power rule again, so it's by saying this is going to be base 3 to the 3 times negative x plus 1. Okay. Remember now, right now I'm writing this as multiplication. Okay, I'm not writing this as negative 3x plus 3 on the exponent. If I do that, then I can rewrite them into something like this. But I don't need to do that. I don't want to have any more bases than the 2 I have, because I know when the bases are the same and the bases are equal, I can simply set their exponent equal to each other. So I'm going to go ahead and multiply them as I write them. This is going to be 2x minus 8 equal to negative 3x plus 3. Alright, move the negative 3x over, that becomes 5x. Move the negative 8 over, that will be give me 11. So my answer, x equals 11 over 5. Alright. So once I multiply once I set the exponent equal and multiply them out, okay, these are linear equations. This one will actually end up with a quadratic. So right now, this right hand side, okay, is 2x squared, 2 to the x squared plus 7x. So what I can do is rewrite this as 2 to the x squared times 2 to the 7x. I can write it this way, but I don't want to, because that actually give me 2 bases. Okay, I just want to make the base the same right now. So I'm gonna try to make the base 8 into a base 2. So 8 is 2 to the 3rd power. But the whole thing on the, so 2 to the 3rd is an 8, but outside the 8 is raised into a negative 4 power. So that means this part is really 2 to the negative 12 power. So when the bases are the same and the bases are equal, we set their exponent equal to each other. So here I'm going to go ahead and write this as 2 to the negative 12. So I will set it equal to negative 12. Alright, this is a quadratic equation. So I'm going to move my negative 12 over. So that'll be x squared plus 7x plus 12 equal to 0. Alright, I'm going to factor this. I think 4 and 3 will do it. Alright, set each factor equal to 0. My answer, x equals negative 4 and the other x equal to negative 3. Then check it, you know what I'm saying? Make sure these answers we come up for x going back to the exponents, okay, will actually equal up to what's on the other side. Alright, this one right here. I know 49 can be written as 7 squared, but if you really think about it though, this 7 on the left side is actually over 1. That means the 7 is on the top. The 49 is in the bottom. That 49 can be written as 7 squared. But the base 7 is in the bottom. The other base is on top. So I want them to be on the same side. So what I'm going to do is move my 7 squared over the 49, flip it to the other side of the fraction. And that will make my exponent negative. Okay, so I can level up. I can be on the same level as the base on the other side. 7 to the 3x minus 5. So now when the bases are the same and the bases are equal, we set their exponent equal to each other. So once I set them equal to each other, this is a linear function. So this is going to be 3x equal to positive 3, I believe. So x equal to 1. Okay. Now this one, if you really think about it though, this is 2/3. This is as simple of a base as I can have. But this is 27 over 8. So 27 over 8 can be rewritten as using a base 3 is 3 to the third over 8 is 2 to the third. So using the power rule B idea, okay, where normally we multiply the exponent inside, now we're going backwards. Backwards means since both bases is to the same power, I can rewrite them as 3 over 2 whole thing to the third power. Okay, but remember now, on the outside of 27 over 8, there was a relation to the x power. So whole thing to the x power. Outside of here is to an x power. So that means outside of here is another x power. So power rule again, that's going to be 3 over 2 to the 3x power. Alright, but the base 3 over 2 is still different than the 2 over 3. So how can I make 3 over 2 the same as 2 over 3? By flipping them. Remember now, if I will flip the 2 to the top right here, that becomes 2 to the negative 1 power. 3 flip to the bottom will make it 3 to the negative 1 down here. So both exponent has negative 1 power. So if we push it out on the, so if we multiply the exponent, that will actually make the outer exponent 3x into a negative 3x. So if I flip my bases, both base will have a negative 1 power. 3x times negative 1 times negative 1 will make that 3x into a negative 3x. Okay, so this whole right hand side is going to end up to be 2/3 whole thing to the negative 3x power. Alright, the other side is 2/3 whole thing to the 2x plus 2 power. So when the base are the same and the base are equal, we're going to set the exponent equal to each other. I'm going to move my negative 3x over, that gives 5x equals negative 2. Excuse me. Move the positive 2 back. So my x equal to negative 2/5. Alright. Okay. Alright. And I'm going to end this lecture video here, okay, with this problem. Okay, manipulating our exponents so we can make the base the same, so we can set the exponent equal to each other. Alright, thank you for watching.